everyone. Am I audible?
Yes.
All right. Dear authors and invited guests, welcome to Technical Session 3A. My name is Shobhit Pokhriya, and this session would be moderated by me. On the behalf of Global Knowledge Research Foundation and GR Scholastic LLP as the international organizer technical partner, Trinity University as the university partner, Venovate DMC as the local organization MICE partner, and Springer Nature as publication partner. It is my great pleasure to welcome you all to the 8th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2024, Las Vegas, USA. The 8th edition of the conference is being organized in hybrid mode. The physical event was organized in Las Vegas, USA on 23rd May 2024, and the virtual event is being held through Zoom. This is 24th May 2024. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session. So starting on with the chair, first we have is Dr. Sachin R. Jain. He's currently working as an assistant professor at Oklahoma State University, USA. He has more than 19 years of teaching and research experience in the field of computer science and engineering. His research interests are wireless sensor networks, artificial intelligence, Internet of Things, blockchain technology, machine learning, pattern recognition, and digital image processing. Welcome, sir. Please give us some welcome remarks.
Thank you, Shobit. Thank you very much. Am I audible?
Yes, sir, you're audible.
Yeah. So, ladies and gentlemen, and dear participants and distinguished guests, it's my honor to welcome you to the 8th International Conference on Information and Communication Technology for Intelligent System 2024. As a session chair for this session, I am delighted to witness such a diverse, talented, and accomplished group of individuals gathered here, representing a wide array of background and expertise from around the globe. Over the next 1.5 hour, will have the opportunity to engage with the wide range of topics spanning disciplines and continents, all united by a common goal, the advancement of knowledge and innovation. Without further ado, let's begin the session. May it be a time for of fruitful and enlightening discussions, valuable insight, meaningful connections, and new discoveries. Thank you and welcome all.
Thank you so much, sir. Next up we have is Dr. Shafi Pathan. He's currently working as professor in Department of Computer Science and Engineering, MIT SOE, MIT ADT University, India. He has an academic experience of 23 years working as a technical director for Machine Math Technologies, Pune. He has been handling project management, deployment of project, and resource management. Welcome, sir. Do you have some welcome remarks for us? All right, let's move on to the presentations. So first up we have is Ms. Kazi Fatema, who is going to present a paper, a novel two-stage classification architecture integrating machine learning and artificial immune system for intrusion detection on balanced data set. Ma'am, are you there in the session?
Yes, Shobhi, thank you so much. I'm here.
All right, you may present,
Am I
ma'am.
visible and audible?
Yes, ma'am,
Am
you're
I
audible and
audible?
visible as yes, yes.
Thank you. So, as Shovik has already introduced me, so I will skip this part and I will totally dive into the topic. Data breaching has been a common scenario in cybersecurity field in these years, and for instance, I could example one of my country's data breaching incident that was from the Office of the Registrar General Birth and Death Registration. Over 50 million data have been leaked in this single scenario. So updated ideas are more of a need in these days, and that's what motivated us to this research. So when we dived into this research, our first objective was to create an idea that would be trained on a balanced data set to distinguish between the performance metrics of a balanced data set idea system and of an unbalanced data set idea system. And after that, we focused on to introduce a unique feature extraction and classification model, and we also kind of played with our model, and we created different versions of our model with different techniques, and we compared their results. So when we started our research, we found some major limitations, and one of them was that there is really a scarcity of balanced dataset in network activities. So, and also we have looked after a lot of researchers that we found very few research are there that are keen to implement balancing technique on existing data set to train their IDS system. And the existing architecture of feature selection methodology or feature extraction methodologies are very complex, and also the common models that that have been used over the years. And also the false positive warnings are one of the major limitations of our field. So our focus totally grabbed. We totally dedicated our focus into building a IDS system which will be on balanced data set, and we also tried to introduce a new architecture combining three known architecture into one. So I will totally, this is our background studies, which I already stated the limitations. I'll totally go to our system architecture. So our system architecture comprises of three steps. The first one is obviously the data collection. We have used CAC IDS 2018 dataset, and this is a huge dataset, and it is a real life network dataset. So we have actually took 10,000 instances from the dataset, and in these 10,000 instances, there are 8,000 instances of benign data, 79 instances of FTP brute force, 870 instances of SSH brute force, and 197 of GoldenEye DOS attack, and 54 instances of slow loris DOS attack. After that, our data inspection and pre-processing step. So we at first standardized our data using standard scalar technique, and after that we converted our categorical values into numerical values for using label encoding. And our next step comprised of splitting the dataset into training and testing data, which training data occupies 80% of the data, and testing data occupies 20% of data. And the balancing technique that I was talking about, we actually implemented our balancing technique on the training data so that the model totally can learn the difference between the attacks and identify them well. So we have implemented our balancing technique on our training data, and then we have gone on to our next step, that is our model implementation. So our model, this is the whole architecture of our model. There are three models that we have named: model A, model B, and model C. So our model, all of our three models has multiple stages. First two has similar stages. They have three stages or three layers. model A have first layer of feature elimination, for which we have used SVC RFE technique, and for our second layer we have used DCA for feature refinement, and in our third layer we have used SVM for classification. And model B is slightly different from our model A, that we just changed the first layer SVC RFE into RF RFE, and third layer SVM classifier to RF classifier, but the feature refinement layer we have kept the same. And our third model, we have totally eliminated the second layer of feature refinement. We just kept the feature elimination layer of AdaBoost RFE, and after that we classified with the AdaBoost classifier. So about DCA, I want to say why DCA, because DCA is an algorithm which work like our human body. Like dendritic cell totally intrigues our immune system whenever it recognizes any intruders in our body. So it is a great artificial immune system algorithm to work with in animal in intrusion detection. So our dendritic cell algorithm works as follows. We have to initialize the DCA, and it will activate the dendritic cells, and it will predict the levels and update the dendritic cell about the levels. It will find the uh, intrusions as signals, it will label them as safe, danger, or pathogenic associated molecular PAMs. And after that, it will run the DCA feature refinement and select top features which are safe for the system. And after that, it will print the refined features which will use for our further identification of attacks, and it will complete its actions with this. So our setup was a Core i5 processor of 2.4 gigahertz, 4 GB RAM, Microsoft Windows 11, and we have done our coding in Jupyter Notebook and slightly on Kaggle Notebook as well. And so we have used oversampling for balancing the data set. Before using the balancing technique, we have, as you can see in this slide, this is highly imbalanced data, right? So after using balancing technique of oversampling on our data set, it has equally distributed the attacks on the data set, and for that in our training phase, the model could really learn about the attacks well. And our model A, which extracted 20 attributes from 79 original attributes in layer 1, and DCA refined 10 features from the 20 extracted features. Model B did the same kind of output, and model C slightly give us only 15 features at last. So this is our training and test accuracy comparison. Our experiment 1 or model A has shown us 100% accuracy both in training and testing phase, model B as well. But our model C, it has shown us 99 accuracy, which is not bad as well, just slightly lower than the other two. So this is our confusion matrix. So for our model A, in our training phase, we can see that our data has been equally distributed to the to every attack types, and for our level 0 attack or benign data, which was not actually an attack. So it has totally identified 6,338 instances from 6,341, which is quite a good performance. And for other four attack types, it has shown the 100% accuracy. In testing phase, as we have only used our oversampling technique on training phase, in testing phase, our remaining data has been used. So in testing phase, it has also performed well. From only benign data, in benign data, it has misread one data, but in other levels, it has perfectly shown its efficiency while identifying attack types. For model B, we can see that only in level 4, it has misread 9 data out of 6,341. But in testing phase, it has also shown 100% accuracy, except for our level 0, it has just misread 1 data wrong. And for our third model, it has we can see that in training phase, for level 0, it has misread comparatively more data from our first two models, which is 69 data in total, and for level 0. And for level 2, it has misread 136 data, and for level 4, it has misread 9 data. That's what really lowered its performance efficiency from the other two. And in its testing phase, it has misread 17 data for level 0, and 1 data for level 2. So the rest is quite impressive here.
Fatima ma'am,
Yeah.
your 10 minutes are over. Can you please?
Oh, okay. Thanks for reminding me. Yeah, sure. So for our future scope, we are as we have got tremendous good results with 10,000 instances, we believe we can get a better performance while we use the whole data set. And we also want to explore other balancing techniques other than oversampling and undersampling. We also had implemented undersampling, but as it already lowers the data volume, that will be demerit for our model. So we kind of could prove our point of balancing the data set, which could give us a better IDS system, because why these data breaches are happening after having so much researchers on IDS. So it could be many reasons, and we really think that balancing training the models on a balanced data set can make our models more efficient on identifying or detecting detecting the attack types. Thus, we can get better IDS system with integral of cybersecurity systems to stop this data breaches in this modern world. So that was all. Thank you for this opportunity. I'm open for question now.
Well, it sounds like your work addresses a critical aspect of cybersecurity, ensuring the effectiveness of IDS in the face of evolving threats. I have few questions.
Yeah,
What is the
sure.
significance of dataset imbalance in intrusion detection?
So at first, dataset imbalance can give us misleading results. Like our model can show a very good performance, but it's not trained on all types of data. Like if we can see, let me just slide. If I can see this bar chart, so DOS attack slow low race has literally 0.05% from the whole data set. And if we train the model on this original ratio of data set, there is hardly chances our model can get trained on this one, right? So it won't have any efficiency on detecting this attack, so which can lead us to future breaches, you know. So we it will get trained well on the attack types which volumes are larger. So that's what the imbalanced data set can give mislead to us to
Okay.
inefficient IDS systems.
How does the DCA contributes to the improving of intrusion detection? How it contribute
Yeah.
or how it ensures that it is working well?
So DCA already has the reputation of giving good performance on anomaly detection. So, and we have used it with layers. At first, we have used the feature elimination, which is recursive feature elimination. We are eliminating the recursive features already. And after that, DCA actually work like our human body. What can be better for an intrusion detection system rather than a human body clone, right? Our human body are very prone to like identifying intruders, any virus, any bacteria, right? So DCA actually implement that uh, technique to identify any intruders, any kind of anomaly, and it also uh, uh, notify other systems to about this sorry, it also notify the security system about this anomaly, so that the prevalence intrusion prevention system can work better with DCA.
Okay, one last question. Have you compared your experimental results with any existing work that has been carried out earlier?
We didn't do it like in our paper, but we have compared with many like DL model and FL model or ML model, which gave us 70%, 80%. But we haven't recorded it officially in our paper. But we have, or we haven't run those code on our experiment system. But we have done the academic comparison.
Okay. Thank you so much.
Thank you so much, ma'am, for the presentation.
Okay, thank you so much.
So next up we have is Ms. Diksha Jatangi, who is going to present her paper, DTROL, leveraging graph neural networks with attention mechanism to detect state-sponsored trolls. Ma'am, are you there in the session? Okay, you can start on with the presentation.
Hello everyone. I'm Diksha here to present our project Troll, leveraging graph neural networks with attention mechanism to detect state-sponsored trolls. So this is a quick overview of what I'll be presenting today. First, we'll start off with the problem statement, move on to the literature survey, identify the objectives of our study, take a deep dive into the data we've used, look into the approach that is proposed, and the implementation method, take a look at the results that we've obtained, move on to the conclusion, and then I'm open for questions. So I'm sure all of us have enrolled ourselves in one or the other social media platform, from Facebook to Instagram to Reddit. All of us have significant influence on the social media platform that we are on, and majority of us get our news and information from social media. But there are downsides to it. So many of you would have heard of trolling, but let me tell you, trolling is one of the methods that has been employed to spread misinformation uh, uh, for political agendas and sow discord and amplify conflicts through the social media platforms. And one such instance can be seen during the 2016 presidential elections. It's been identified that certain trolls that have been identified later as Russian trolls because of the region of the trollers belonging to, that these trolls had a significant impact on the results of the 2016 US presidential elections. So it becomes very significant to identify such kind of trolls in maintaining the sanctity of the platform and in order to identify the truthfulness of the content and detecting such trolls. And hence, we are here to we started our work on this particular topic, and we have chosen a platform as Reddit, as majority of the content that's on Reddit is open to a large amount of people. So on identifying the present research work that is there on the Russian trolls, it has been identified that majority of them are comment centric. So basically, when a troll comments, the present approaches look into the text features of the troll mainly in order to identify if it's a troll or not. These strategies have been employed over a period of time, and trollers have been trying to adapt for uh, a different kind of behaviors in order to trick people into believing that they're not trolls in order to escape from the system. So let's take an example. A troller has commented such an adorable cat on a post, so that makes him a non-troll user. But he has been commenting a lot on the trolling content as well. But using regular machine learning models can make this troller go unnotified because of the non-troll content that he's also posting on the platform. So hence, identifying better techniques in order to improve the accuracy becomes essential in order to identify such kind of trollers. So to identify this and to look into the problem in much deeper, we did a literature survey, and we identified that these trolls in fact had significant impact on the social and political decisions. And hence we researched on the methods that were already there. We identified that there were no graph neural network based methods, and it can be seen that social media platforms are a kind of graph network, and graphs in general can accommodate for a more comprehensive analysis because of the uh, structure they can accommodate. So that was one analysis that we came up with. And also it was identified that, as I gave you an example of a troll user that was commenting different kind of ways in order to escape from being identified as a troll user, adapting different kind of methods also becomes essential. Hence, we went through different graph neural network models as well that would help us identify or analyze this graph data that we have proposed, and we'll be discussing the data now. So before that, we identified the objectives after the literature survey that we thoroughly did. Firstly, our objective was to identify such trolls on the social media, and then we wanted to propose our own graph-based solution for this that combines not only content analysis but also does an analysis of the user that is posing such comments. And then we wanted to identify a graph neural network that helps in analyzing this kind of data better. So let's dive into the data that we're considering. So the data we have used is actually a list of Russian trolls data that interfered in the 2016 presidential elections, and this was officially released by Reddit and it was made available on GitHub. So this data consists of around 7,000 comments, and we've also extracted an equal number of non-troll users from that period in order to balance the data. So how do we understand whether a particular behavior is of trolling or not? So that's where we've done the data analysis to get a deep dive into the understanding of the kind of behavior that the user and his commenting has. So in comparison to a normal user, a troll user commented more frequently on the platform. So an average of 30 plus comments per day was observed for a troll user, whereas the trolling comments were not more than 20 for a non-troll user. And the content of a non-troll user was significantly disliked. That helps us identify that it was more of offensive material. The non-troll users also had certain political entities in their comments, and identifying such features helped us distinguish whether it was a troll or non-troll user, and to further extract this data for the features that we're considering. So this is the graph that we've come up with. So after obtaining a tabular form of the graph that we had, we have converted this into a graph data. So we have proposed this data structure of the graph data. So we are considering a heterogeneous data for this approach, where the user becomes the central node, and he's linked with all the kinds of comments that he is posting. So this is a subgraph. So each user node is connected to a couple of comment nodes that he has done, and so the entire graph data consists of multiple subgraphs with user node as a central node and adjacent comment nodes. So for each user node, user behavior is identified with the following features that can be seen on the image on the right. So the created UTC is basically tells us about the time duration during which it was created. It was identified that the trolls that were involved in that particular period were created during the period of 2016, and 14 to 16 and the adjacent years. And the link karma tells us about the kind of commenting that the user has been doing. It indicates the good or bad reputations that the user has for the post that he's been posting. And the comment karma gives us the comments, the kind of reputation he has for the comments that he's made. Is moderator or not is a term related to the Reddit platform, helps us identify whether he's a moderator or a general user. And so if he has a verified mail as well, helps us identify whether he is an authentic user or not. Those were the user features that we've considered. And for the comment, we have certain features that are here that you can see. It identifies the subreddit that it comes from. It identifies the time during which it was created again, and the number of entities, which gives us the kind of political references that the comment has. Polarity that helps us identify between the kind of negativity that the troll comment has. The Fleshkin card score gives us the readability of the comment. It was seen that the Russian trolls had a different kind of English text that was used. So it gives the readability of the comment. The word count, punctuation count, uppercase, word count, these were all identified after doing an analysis onto the troll user and a non-troll user comments. And these helped us identify that these had significant difference between a troll user and a non-troll user. So hence, we have these features after doing thorough data analysis of the data that we got from the platform. Okay, so here's the interesting part where we move on to our architecture that we've come up with. So firstly, the data is extracted from the social media. It's pre-processed, where we've done cleaning, restructuring, and extracted the features that we want. And this tabular data further is extracted for graph features for node embedding. So after performing node embeddings in the features for comments as well as for users, we have the comment nodes and the user nodes. And on mapping each user node for the respective comments that he's made, we have the corresponding graph structure that you can see. It consists of multiple subgraphs. So this graph data has been fed to the graph neural network. We have considered a couple of graph neural networks. This was the final graph neural network. We'll be discussing that in the further slides. So on training this graph neural network on the graph data, we perform node classification, basically whether a user node is a troll user or a non-troll user. So this is the overview of the architecture that we've come up with. So the implementation gives a deep dive into the kind of operation that we have done. I would like to explain it from here itself. So the comment nodes, for the comment nodes, we have used certain NLP operations to extract the features from the data that we've got. And for user nodes, we have used a library called prof from Python to extract user metadata. And we have constructed the graph using Torch Geometric, which is a library available for Python. And this is a heterogeneous graph with two kinds of nodes, as you can see, the user node and the comment node. And we've made use of graph attention network because of the attention mechanism that it has, which has given us results that stands out compared to the other graph neural network models that we've considered, which is our next slide. So these are the graph neural network models that we have considered. We've considered graph attention network, graph convolution network, and graph sage. all for the purpose of node classification of the user node, whether it's a troll or a non-troll user. So these are the
Ma'am,
results. Yes.
this is general reminder for the completion of 10 minutes. Thank you.
Yeah. Thank you. I'll be finishing it fast. So we can see here the graph attention network stood out with a very good accuracy of 88.4 and 85.90. And we can see that in the overall performance on the right here as well. So this is a click in into the model that we've constructed for the GAT. And these are the overall scores that helps us in classification tasks. So F1 score gives us a balance between the precision and recall, and 0.9 was the score for GAT, which is a very good score in terms of classification when compared to other models as well. So these were the overall scores, and this stood and graph attention network stood out. So in conclusion, we have identified that user behavior, in addition to text features, helps us in compounding the results that cannot be only obtained by text features. And we have modeled different graph neural networks for troll identification for the purpose of node classification. And we've identified that the accuracy we've got is improved as compared to the proposed methods using similar data. So we have given an approach that incorporates dual feature behavior through graphs. And in the future, this work can be extracted by improving the heterogeneity of the graph. So basically adding image data as well to the graph. So for now, we have comment and user data. So even the image data can further be analyzed by adding image kind of nodes and making it a multimodal graph. These are the few references. And thank you. We can have the questions.
Well, this work seems to address a pressing issue in the contemporary society. It's good work. I have a few questions. The first question is, what is the graph attention networks? The GT, you didn't explore about that. Yeah, what's that? And why this has been chosen over the other competing GNN models? Why do you choose the graph attention networks over that?
Okay. So basically, the task of all GNN models that we've identified for node classification in our case, and these are the models that are good for node classification based on our literature survey that we've got. And one reason why graph attention network stood out is, so as I showed, as I mentioned, a user can have different kinds of comments that he has made. Do you want me to share the screen?
That's okay, but just elaborate on what exactly is the graph attention networks. What do you mean by that?
Yes. So what graph attention network does is it aggregates the information for a graph with its neighbors by adding attention to each of its neighbors. So by giving more weightage to the troll comments that a user has done, by giving more attention to that, by adding weights, so it learns by giving weights to each of its neighbors. By increasing the weight of such comments, identification becomes easier as compared to graph convolution network and graph stage networks, where it just aggregates the information from the neighborhood. So graph attention network helps in adding weights of relevant weight to its adjacent neighbors. So since our model has a shallow network as well, which is each central node has one neighbor node, identifying the weights of respective neighbor nodes becomes essential in node classification.
So in what way can the findings of your study be applied to mitigate the spread of misinformation and trolling behavior on a social media platform in the real world scenario?
So basically, this work has been done for the Reddit platform. We've got very good data from the Reddit platform. This can be extended to other platforms as well. We can, in real time, deploy this and again, through API, get data from those platforms. And so we can incorporate features of those platforms as well. As I mentioned, certain features that were there for the user from the Reddit platform, it can be added to, we can extend this to other platforms as well. And make it a more comprehensive and robust model.
Is there any challenges you faced during the implementation? Any challenges like encountered in implementing this approach?
Yeah, so initially so the graph data was completely by our own. So we had different methods which failed, and then we had to identify what went wrong in terms of identifying what are actually being incorporated for identifying whether it is a troll user or a non-troll user. So we came up with different graph models and architectures for our model. And finally, on this particular architecture stuck because it incorporated for a overall, like feature incorporation.
Okay, thank you so much.
Thank you so much.
Thank you so much, ma'am, for the presentation.
Thank you.
So next up we have is Mr. David Rivas Lileliu, who's going to present his paper on differential performance of satellite navigation in urban and rural NDs of Ecuador. Sir, are you there in the session?
Hello?
You may present your screen, sir.
Okay, thank you. Good afternoon. My name is David Rivas. I'm from Ecuador. I stayed in Universidad de las Fuerzas Armadas ESPE in Ecuador. And today talk about the experiment to the performance of the satellite navigator in principle in Ecuador and make a resolution in compare the urban and rural comportament these elements. First, in Ecuador have a GNSS performance in the Ecuadorian Andes region. What is the important to this study? In Ecuador, Andes region is very interesting for the use technology because have many mountains. Mountains have more the 1600 meters of the level of the Maya, and other elements for this elevation. In this area, have those two important sections. First, the urban. In urban, have many homes, many houses, and other buildings, and have interference for GNS equipment, but in the rural area have different elements. For example, have many streets, or in other areas have glacials, in other areas have any performance of the heart. Other elements to this study is register this information, because the GPS or the GLONASS information you can't receive in only a platform for the personal of the or personal platform or different platform principal for the other equipment for personal or different elements. But in this study, designed the system for the data acquisition. In this element, we can evaluate different systems. For example, in the area, we have a GPS, GLONASS, Galileo, Velium, INSS, QS, IS. This is the GNS system in around the world. But in Ecuador, those systems work everyone. The principal system to work in Ecuador is GPS and GLONASS. Galileo have a signal, but it's a low power and have any difference. But in America, GPS is the more system to use for the navigation or the geospatial reference. For this element, we have building interface to acquisition information. This interface for the development in Python and use to the acquisition using the model is IMM8Q module to register the geo position. This element to configuration in MicroPython and use Python to register the information. The information have a different related acquisition data. In the any experiment have more than 2,000 of the registered for this experiment. In this element, have a first location is Quito. In this location, have 100 samples for this element, and have this graph. Why is the interesting for this meeting? In red color have the original position. This have use a military matters, but in blue have a medicine with a model. We have different the two methods. This error is proper for the um, problems or noise for the buildings or the others parameters in the urban system. You have this analysis with a 5% the elements is have a good measure, but have a error for the 4-5%. But the GLONASS have a different comportament. You can see the other graphic to the measure. It's definitely different for the GPS. Have the different elements. White use GPS and GLONASS combined. What is the combined? You have a two measured and combined with proportional the elements in the data set. Next experiments use in the rural area. You can see the ESPE campus in Sangolquí. We have an area, don't have many buildings, and can't other measure. This is very interesting graph. In GPS have low error. The error is just 1 meter. But in the GLONASS analyzed, the error is diminished to 2 meter, but don't have a difference for the real measure. But combined two measure have the maximum error is 30 centimeters. It's very interesting, very interesting because use two systems to diminish the error. The conclusion for this word is don't use one system for GNSS because for military system or other enterprise user this information or control the information, you use or meeting other error. This error is have problems to the measure. The more important combinate the GPS and GLONASS data improvisation, current and precision. It's very important this result because use those two systems, you have low error and don't dependent the only measure. And different elements, you understand the capacity, the GNS capacity across the different measure, in special in the Andes region. Thank you for your attention. Thank you for the ESPE, UNACH, and UPS University and the CITEC project for financing this experiment. Thank you.
Well, how does the combination of GPS and GLONASS contribute to enhancing accuracy? How they ensure that the accuracy has been improved?
it includes for include to measure is using a algorithm to statistic. In the statistic algorithm, you combine the results of the GPNs measure and the GLONASS measure. The second form to the combine is a intelligent system for position. In this element, we have a IA algorithm to combine this in the word start in the word in this moment. This result don't have in this moment, but is the combination is a statistic for this experiment.
How to find out the error in your experiments? You have mentioned that maximizing the error for only 30 centimeter, or what is the procedure, or how do you calculate the error in your experimental results?
The precision is 85 for the combination T2 system. This very, very interesting, but the other system is it's important the enterprise control the GPS or control GLONASS for security use filter errors, filter information to have a different position because this error introduced in the measure it's because the security. And this experiment reduced by this error, but the precision have a problems because the enterprise have a introduced error in the measured in commercial measure principle because in the military have a different comportment.
Okay, thank you so much.
Thank you.
Thank you so much, David, sir, for the presentation.
Thank you.
So next up we have is Mr. Fernando Saicedo Altamirano, who is going to present his paper on experimental development of scripts for data network automation using the Python programming language and open source tools. Sir, are you there in the session?
Yes, good morning, everyone.
Good morning. We present your screen, sir.
Okay, can you see my screen?
Yes.
Thank you. Well, today I'm going to talk about the experimental development of scripts of data network automation using Python programming language and open source tool. In this research, we have been working principle because of the problems that network administrators are taking nowadays because of the growth of communication infrastructures. It has involved the development of service and increase in bandwidth because of the evolution of the industry 4.0 and web 4.0 because they work with a lot of multimedia data. So in the network infrastructure, we need to upgrade make maintenance in the devices so we can approach to the bandwidth that those services request. So it's very difficult for network administrators to deal with these problems. Also, because of the growth of the cyber attacks, network administrators have to deal with that security. And if someone is trying to attack our network, it it could cause that the devices can reset themselves and we can lose the configuration of those devices. Also, we can, here in Ecuador, we have a lot of issues with the electrical network. We have a lot of blackouts. So it causes that the devices, if they have not a good infrastructure with UPS, for example, they reset the devices and we are losing the configuration. So the network administrator have to take care of that and make the configuration again, doing it by manually, and it caused the service interruption for the people who are working on network enterprises, and it becomes an economical loss also because the stoppage of the production process. So it's very difficult to deal with that, especially when money is involved in the factories, for example, and in production environments. So there are a lot of research that are trying to solve or help to re-enable the networks. For example, by doing a continuous monitoring of the network performance. But for this, we need the network administrator to be watching to the screen every time so he can get some notification of faults or trying to detect some attacks to the devices. And it's a lot of work for people of the ECT to be dealing with that. So another solution is to have the network automated. So the automation of the network consists of some scripts that are previously developed that contains all of the configuration commands that we need to make the network available to access. So we have proposed a methodology based on 3 stages. The first stage consists of the network itself. In this research, we have worked in a laboratory environment, so we don't have to deal with loss of information in in a real environment. So we have proposed a topology that can be similar to a topology in a real network. And also we have choose some services and protocols that are often used in enterprise networks. And all of the configuration that involves to get those protocols enabled. The next stage consists of the automation system. So for the automation system, we need to develop first of all, install the tools that we need so the system can work. And next, develop the scripts. So as I said before, the scripts are going to have all of the commands that we need to reconfigure the devices. And finally, once we have both of them working and tested, we go to the execution step. So in this step, we have to join the network and the automation system by making a secure shell connection. We have used secure shell connection because it is a secure protocol that we can make a remote connection so we can reconfigure the devices and apply all the changes that we have. And also we have considered a feedback, so we can know exactly that we are working on the device and we didn't lose the connection, for example. In this layer, we can see the topology that we have chose. It consists of a MikroTik router that is connected to the internet. It's working as a core device. In this router, we have connect two switches, one from Cisco and one from HPE. It's important to mention that we wanted to test different brands, so we can analyze the results, not just with one brand. And we also have developed wireless network using a Cisco access point. So in here we have enabled 3 SSIDs. They are also matched with the VLANs that we have developed in the router and also in the switches. And finally, we have the server that is running the script for the automation connected to one of those switches. The open source tools that we have choose for this investigation is, first of all, Visual Studio Code. With this program, we have choose this program because it is very easy to work with Python language. We have also choose Python because it's the language that nowadays is being the most used for this time of automation. We have also used the Python library SSH because it let us work with different brands of devices and also make the secure connection. And finally, the Paramico library that has all of the commands that are that work with most of the network devices brands. Next, we have the script development at the automation system. Here we can see a diagram that shows us the first part that consists of the connection from the server that's holding the script to the devices. And here we have, because of the use of the secure shell protocol, we need to use username and passwords and make a connection through an IP address that is previously configured in the devices. So
Fernando, sir,
once, yes.
this is a gentle reminder for the completion of 10 minutes.
Okay.
Kindly wind up. Thank you.
Okay, so once we have connected the devices, we start by a timer. See, we enable a timer, and then we make all of the configurations by the commands that are on the script. And finally, we finish the timer so we can get the amount of time that is taken to all of the configurations done on the devices. So here we have some screenshots of the commands that we have used for the connection. Here we can see the feedback that tell us that we are established the connection to all of the devices. It's very important to notice the timing that we are taking here. So we start a timer, we make all of the configurations of the protocols in each device, and finally we end the timer. We get a feedback with the amount of time that have been taken. here we have we did this test both in a simulation mode using GNS3 software and also in physical devices. And here we can see the result of the amount of time that that the system take to implement all of the configurations in the devices. And finally, here we made comparisons, the amount of time that is taken for reconfiguration of the devices by doing it manually, typing the commands by backup file that contains all of the configuration, and using our automated system that we can see that all of the configurations are done in just 1 second above in all of the devices. So it's the time that the system, the network are going to be without connection, for example, if something happened to the network. And finally, in the conclusions, we did a research for choosing the right programs and libraries for this test. We also developed the network and all of the configuration with enterprise protocols. Finally, we did we take the amount of time that is taken by doing the restoration by manually, by backup files, and also by the automated system. Thank you all for your attention, and now I open for any question.
Well, what is the significance of using the Paramiko library with Python language for the network automation in your study?
Yeah, that library, we also analyze another library, for example, the Paramiko library, the Telnet library, but we had some problems, for example, with the HPE switch. With the Paramiko, it didn't get a very good connection. We working with the Telnet library didn't let us make a secure connection. So that's why we chose the I'm sorry, the Paramiko library.
Paramiko.
We use the NetMiko
So
libraries too. Yeah.
So how does your research demonstrate the effectiveness of automated script compared to the manual reconfiguration and the backup archiving methods?
Excuse me, can you repeat the question?
How does your research demonstrates the effectiveness of automation scripts compared to the manual reconfiguration and the backup archiving methods? How do we compare? What are the advantages of automated scripts compared to the manual reconfiguration and the backup archiving?
Well, the development of the automated scripts, if in the first step is kind of hard, but the advantage of that is when you have one script, especially for some tasks, and we can develop more scripts that do exactly configurations, so we can make a main script that can call all of the scripts, and they can work all of them together. So especially when we are working in networks that are involved in security, it's very easy to work with that once we have developed all of the scripts for every task that we need.
Okay, thank you so much.
Thank you.
Thank you so much, sir, for the presentation. Next up we have is Yang Chen, and he's going to present his paper FFAD, a novel metric for assessing generated time series, data utilization, Fourier transform, and autoencoding. Sir, are you there in the session?
Okay, thank you, Shelby. Can I share my screen? Yeah,
Yes, please do.
yeah, can you see it?
Yes, it's visible.
Okay, yeah. Okay, so hello everyone. My name is Yang Chen from Georgia State University, and today I'm going to give a short presentation, and the title is FFAD, a novel matrix for assessing generated time series data utilizing Fourier transform and autoencoder. So to begin with, I'd like to provide some background information. Deep learning has achieved remarkable success in generative models such as GAN, CGAN, and VAE, showcasing their ability to generate realistic images, artwork, and time series data. So an important and still in the air question is to evaluate the quality of generated samples, because this can help us do the model selection, and maybe we can use this metric as the loss function to improve the model further. And two widely used metrics will be the Frisch-8 inception distance, FID, and inception score, IS. Both metrics are based on take advantage of the inception V3 model as the pre-trained model to finish the feature extraction. But difference will be FID is the lower the better, so 0 will be the better. And IS is the higher the better. But in our work, we prefer FID over IS, and the reason is on the right hand. As we can see, there are 4 scenarios, and in each scenario, the first image will be the original image, and gradually we will add some like Gaussian noise on it, and the disturbance level means how much noise we add on it. As we can see, the FID score is monotonically increasing, which means because the quality is decreasing, so FID score should be increasing. But if we look at the inception score, they are flattened or stay flat, or even in some worst case, they are decreasing. So it has limitation compared to the FID. So in our work, we based on the FID. Yeah, so that's the reason. Okay, so next I'll talk about the problem statement and the challenging are faced in our work. So a widely accepted matrix for assessing generated time series is absence. But such matrix is very crucial for time series because we cannot do the visual expectation for time series. It's not applicable compared to image. And also devising a matrix similar to the FID I mentioned, in time series, there is a lack of pre-trained feature extraction model designed for time series. There is an inception V3 for image, but there is no unified model for time series that is already pre-trained on extensive time series dataset. One approach is to train autoencoder for time series data. However, the challenging need to address is we need to handle datasets with varying sequential lengths. For inception V3 is trained on ImageNet, there is a consistent image size, but for time series dataset, even for UCR, each time series dataset has different sequence lengths. So this is another challenge there. So in addressing these challenges, we propose a novel solution called Frisch-8 Fourier transform autoencoder distance, short for FFAD, leveraging the Frisch-8 distance and interrogating the use of Fourier transform and autoencoder techniques. I will provide more details later. And about the data, we mainly use 2 data source. The first is UCR, which is a benchmark dataset for developing and assessment algorithm on time series data. And another is SWANSF. This is a comprehensive multivariate time series dataset in solar flare domain. So this is a real world dataset. And SWANSF has 5 partitions, span 8 years, and each multivariate time series has 60 time steps and is well labeled. And this work will focus on 4 parameters out of 51 magnetic field parameters, and they are shown here. So after introducing the data source, we'll move to the methodology. As I mentioned, the first question need to solve is to handle data sets with varying sequence lengths. And the method we employ is using the Fourier transform, because by selecting a appropriate number of frequency components, we can ensure our time series with a consistent input length. So this is our original data set, and each one is different length, and we can select the number of frequency component, so we can get unified length there. And this will help increase the efficiency of our network, because we don't need to do the padding in the training or in the inference. Another advantage is from shifting from time to frequency domain, it can preserve essential features of the original time series. So we can greatly shrink the length of the time series. Okay, so to figure out how many frequency components are supposed to choose, we design such experiments. We use SmartSAF. This is the blue will be a real time series data, and we use different number of frequency components, try to reconstruct it. Because the time series length is 60, so we use 30 frequency components will be perfectly reproduce the original time series. But actually we don't want to perfectly reproduce, because in that way we cannot show the advantage of Fourier transform. And so we want to use less than 30, and we decide use 20 eventually. And the reason is SmartSAF has only 60 time step, but there are many data sets in UCR can be much longer than SmartSAF. They can be up to 200, 500, maybe 1K time steps. So 220 should be a reasonable choice here. Yeah. So after determining the number of frequency components, we can have such a data set, and we can use this for training the autoencoder, and we can use the MSE for tuning the whole model. This will be the training part, and this slide shows more details about the training and the model selection. We use 97 UCR dataset and SmartSAF, and this will be the setting, and this is the training curve. The green stands for the training MSE, and the red stands for the testing MSE. We conclude that the 3000 epoch should be a good candidate in this case. And also, based on this checkpoint, we also show some examples here. So the blue stands for the original inputs, and the red stands for the reconstructed time series, and we can find is can capture the main tendency of the inputs. That's the goal. We don't want every details, but we want to get the major trend. Okay, so the last part of our methodology will be assessing the effectiveness of FID. After training the autoencoder, the encoder part will be utilized for obtaining a low-dimensional representation. Take a binary dataset as an example. This will be the positive samples, and they will be the negative samples. We go through the encoder, and this will be the lower dimension representation for the input. And we can use such FID. We can calculate FID score. And this equation is inspired by the original FID equation. And it shares the same attribute with the FID. So the lower values indicate a higher similarity between the positive and negative classes. And we also have an experiment for this. So consider a binary class dataset. It can be segmented into training and testing, and each set can be further divided into 2 classes. So there are totally 4 sub-datasets. And we will calculate FID for same class and different class. And this is an example. So what we expect is the FID scores for same class should be as low as possible because they come from the same population, they come from the same distribution. But the FID for the different class, this should be not as low as the same class scenario. And if we see this example, this will be implies that the effectiveness of FID in distinguishing between samples from the same or different classes. I also have more results here on 10 binary classes. So upon observing the result, it's evident that the FID scores for same class comparison are notable lower than those for different class comparisons. This capability will be particularly valuable when evaluating generative for binary or multi-class time series, such as time series models such as conditional gain, because this feature not only enable the assessment of the realism of generated samples, but also facilitating a checking if the generated samples corresponding to their class information. Okay, so summary, in this work, we have introduced a novel metric named FFAD by seamlessly integrating the Fourier transform and the autoencoder. Our experiment result demonstrate the effectiveness of FAD in distinguishing samples from various classes and positioning it as a fundamental tool for evaluating the quality of generated time series data. So before we use data from different classes, but further we can calculate FID for real and synthetic data. And further, FID has the potential to serve as a loss function for refining existing methodologies in time series generation. In our future work, we'll focus on utilizing FID as the evaluation metric to assess the generative models in the context of Flare forecasting task for time series generation. Okay, so that's all for my presentation. And thank you so much for your time. Any comments for this?
Yes.
Yeah.
Why the FID is not suitable for time series data?
Sorry? Sorry, I
Why
didn't get it.
like the can you hear me now?
Yeah, I can hear, but yeah, please.
Yeah, like I need your answer on why the FID is not suitable or is not considered as suitable for the time series data.
Okay, yeah. Because FID is based on the okay, so as we can see here, so will be this part. So FID is for image, which means the I stands for inception with 3 model. So it's a pre-trained model for image. We use the image as input and we get the feature for image from that input. But because it's a pre-trained model for image, so we cannot use it for time series directly. So so we need to train another pre-trained model that's specifically for time series. So that's the reason.
Okay, on
Am I answering your
methodology,
question?
yeah, that's good. On methodology, how does the Fourier transform help in analyzing the time series data? Like a very basic question on the methodology you have used. How does the Fourier
Okay.
transform help in analyzing the time series data?
Okay, yeah. Okay, yeah. So as we can see here, and I think the most advantage of Fourier transform is it can represent the data with fewer like this example. If we represent the time series, it will be 60 time step, but if we use Fourier transform, it can be 3 frequency components, so it's half with the original time series. But this is the I think it's a very short time series. It's only 60 time step. But for, as I mentioned, in some data set in UCR, they can up to 500 or 1K time steps. So if we can use 30 time step to represent a very long time series, it's very efficient. And also, as you mentioned, how the Fourier transform compared to the time series. And we use such like we check the reconstructability, and we can prove that yes, we use fewer components can perfectly represent our original time series. So I think it's much benefit the model training in terms of time efficiency or memory efficiency. Yeah.
Okay, that's good. One last question. How do you ensure the autoencoder is properly trained and avoids overfitting?
Okay, yeah. Okay, yeah. So this okay, so I think to answer this question, we'll use this plot. So we'll train the we'll train the encoder. We have training set and evaluation set. They are separated. So we use the training set to train autoencoder. But as we can see, this is the training curve, and after this point, the training MSE is decreasing, but the testing MSE is increasing. So this means maybe we suffer from the overfitting issue. And I think to monitor such training curve can help us to avoid the overfitting issue. Yeah.
Thank you.
Yeah, thank you so much. Thank you for your time.
Thank you so much, sir,
Yeah.
for the presentation. So next up we have is Mr. Gustavo Schafla A, and he's going to present his paper, that is IP to satellite adaptation level for a bent pipe network using DVB S2/RCS2 standards. Sir, are you there in the session?
Hi, please let me just 1 minute to upload the file,
Right.
please.
Yes, please share your screen, sir.
Hello?
Yes, sir, you're audible.
Yeah, please. Go ahead.
Okay. Can you hear me, please?
Yes, please go ahead.
Okay, thank you. Yeah, I'm Gustavo Chafla. I'm from the Pontificia Universidad Católica de Ecuador. So this time I'm going to talk about an IP to satellite adaptation level for a bent pipe satellite network using the DVB-S2 and the return channel S2 standards. So basically, as you know, the satellite networks are made by proprietary solutions. So the idea behind this is to use the standards in order to try to create or simulate a complete interactive network that can be able to support as best effort traffic, as quality of service traffic. So if you use the standards that are proposed for the European developer standards, is when you use a standard, we can reduce the cost of the equipment. So, but the problem behind this is that the European standardization, the ICTIS, the European Telecommunication Standardization Institute, only propose the model, but they don't propose exactly how the adaptation level of IP traffic could be on this proposed model. For instance, we can see in the picture, this is the interactive satellite network that the ICTIS or DVB-S2 and RCS2 propose. And we can see that they are thinking in advance, presenting them. In this case, we can see that we are two networks. For instance, the initial satellite networks only have one direction, and when one have an equipment that is really expensive, and several receive only satellites station. In this model, we can see that we have several feeder stations, several gateway stations, and in this particular figure, we can also see the RCST, which are the user station that they are bidirectional. So the ICTIS proposed this model, the use of the standard, but they say that how the communication can be made at the satellite level. But the IP level, because as you know, the traffic, IP traffic could be for best effort traffic, like web surfing, or could be quality of service traffic, like this session or subsession that needs several parameters to be identified before the session. So we propose this first approach to do this IP to satellite level using the RSVP protocol for QoS management. Because why we choose RSVP? Because we are able to put in clear paper several parameters of the communication, like latency, like delay, or like jitters, and especially bandwidth. No? That is important in order to make the pattern or make the match with what application needs in terms of the flow, and how the satellite network could be assigned satellite resources in order to cope with this quality of service parameters of the different applications. So in this picture, we can see, you know, where is the IP level will be interacting with the IP model of the OSI-ISO standard, and how is the satellite interaction with this interactive satellite bidirectional that is proposed by the standard. And here's the adaptation level as a logical level with several models, and the principal very detailed information is very difficult to say in so much with this time we have assigned, but in general terms, we can see that the main function of this adaptation level is cope for the satellite traffic control, because there is another issue. For instance, in the satellite network, all the connections are developed in a connection. We have to require the connection, we have to require the resources for the satellite network, but IP by itself is a connectionless protocol. So we have to call, for instance, if we need this Zoom session in this moment, we can say, for instance, we need 128 kilobits per second. But we have to require this amount of data in order of satellite slots. That is because the satellite network needs to cope with connections, flows, all the needs of the IP applications. And this is just an example of the frame structure that we can create in the satellite network. The important thing in this point, because this is completely configurable with the simulator, is that we have a frame size of 30 seconds. And this will be important because we can see in the simulations that we have that all the maximum delay is between this frame size, considering the 2 hop of satellite delay, which is 250 milliseconds. And these are some results. And for instance, the environment, the standard proposed that we can have several resource requests, like RBDC, which stands for rate-based dynamic capacity. For instance, a CBR or constant bit rate, for instance, the voice that we are sharing right now could be coupled with a 70 kbps channel. And we can see in the simulation results that the total jump for a satellite connection is 205 milliseconds, no? Which is the time that the signal has to go to the geo satellite and then return to the Earth. So that is it, approximately 250 milliseconds. And if we add the 70 milliseconds that we have in the framing structure, that shows that the total delay could not be more than 320 milliseconds. And that is what we can see in this simulation. The main objective of this work is to show to the community that there is a tool in order that the community can simulate different applications and different flows or different bandwidth requests with other parameters. We are showing that the simulation has the behavior that we hope when satellite capacity is assigned. And this is, for instance, another simulation that when we have the quality of service traffic, like video or voice, that the total amount of delay is constant in time. As a contrary, if we have best effort traffic, like download files or transfer files, that according with when we have much users, sorry for that, but in this graphic, we can see that if we increase the number of clients connected to the satellite network, the quality of service delay, it maintains constant, even though we have in this case, for instance, in this simulation, 425 voice connection. In contrary, if we increase the number of users that then use best effort traffic, the average delay increase in time. So what about the conclusions? We can see that this is the first approximation of IP adaptation level protocols. As I told you before, there is no, the standard only says about the satellite connection, only about the satellite parameters of the network, but there is no more information about how we can do the adaptation level. So this is a first approach. I know we are using RSVP, but we can use also different services. There's another approach to cope with quality of service flows. So we can see also in the model that the model could be coped with such as quality of service traffic and best effort traffic in the same network, and the model is capable of differences, make some difference in the satellite assignment for different flows. And also the most important thing, one of the most important things, that is the IP connection, which itself an IP connection length, will be served in a satellite network, which is connection oriented network. So for the last conclusion, that I know that because we are talking about the geo-satellite system, which in nature has a 250 milliseconds of delay. But we can do some real-time application, especially which are broadcasted. But consider in the future that there are several systems like Starlink, which is working in LEO, low Earth orbit satellites, which has a delay of at least 6 to 10 milliseconds, which is really low. But the conditions, the problem, for instance, with Starlink is a proprietary system, and we are working in an open system, a standard system, when the community can do some research or take some results. And in the final thing is that working with geosatellite is cheaper than working with proprietary solution. So thanks for your attention. That will be all in my presentation. So I'm open for receiving any question from you.
So what are the main differences between QoS guaranteed traffic and the best effort traffic?
The main difference is QNS, or quality of service traffic, is using for real-time applications. For instance, in this case, we have this Zoom application, and it's very important that we don't have loss of packet lost. We don't have packet loss. We don't have delay. You know? For instance, your voice, it has to be reproduced in the same time that you are generated. Yeah, you know, we have some delays. You know, for instance, could be 10 to 20 milliseconds, but the network has to guarantee the delay and the bandwidth in order that we can have this conversation, this Zoom session. And with best effort traffic, there is no such guarantee. So as the name suggests, the network do the best the best it can do to cope with the traffic that the network is generating.
Okay. How does the proposed adaptation level compare to the existing method for satellite resource allocation?
So this proposal, as I told you, this is an idea. The main thing about this is that we can do some simulation. We can present some results with this proposal because, as I told you before, there are several satellite communication systems, but all of them are proprietaries. So there is no such good information about how they deal with, how they cope with the quality of service with real-time application, with no real-time applications. So I put you this example of Starlink. We know this is a new satellite system that can do really good job, especially, for instance, in zones like Ecuador, when we have very difference in infrastructure in urban and rural areas, but we don't know how this satellite system in cope with these requirements. So it's a way to do it. It's a way to propose a model to the community in order that they can simulate the applications and build a cheaper satellite system, especially for developed countries like Ecuador.
Okay, one last question. What are the potential real world applications of your research?
The potential is huge because as I told you before, the satellite network, especially with with geo satellites, geostationary system, with networks like this, we can have user station cheaper than before. We can buy a RST user station by about $200, $300 compared to 10 or 15 years ago when we have 2,000 or 3,000 stations, US dollars stations. So especially in Ecuador, when we have concentrated in urban areas, the telecommunication infrastructure, but in rural areas, there is no such infrastructure. The potential is huge. But we need a tool in order to simulate the satellite capacity and how this satellite capacity, which is very limited, can cope with the real necessities of users.
Okay, thank you so much.
Thank you to you.
Thank you so much, sir, for the presentation. Now, at the end of the session, I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during this 8th version and all the previous 7 versions of the conference held in Asia. We will be happy to have you in the 9th version in 2025 as well. All presenters would be getting their digital certificates through email within 2 working days. Further, all papers have already forwarded to Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2024. I also thank our session chair, Dr. Sachin Jain, for being with us, and a token of thanks for Sir.
Thank you. Thank you so much. Well, thanks to each of you for your active pitching experience to witness the depth of knowledge and expertise present in the session. I would be remiss if I did not acknowledge the hard work and dedication of the conference organizers, sponsors, and volunteers. Your tireless efforts behind the scenes have been instrumental in making this event a success. So thank you once again for your participation and contribution. I look forward to our paths crossing again in near future. Wish you all the best and thank you so much.
Thank you so much, sir. And this is the token of appreciation. And before ending the session, I would request all the participants to kindly turn on their cameras for a quick snapshot. Thank you so much, everyone. Thank you so much.
Thank you.
Have a good day. Bye-bye.
Thank you.